All right, so at this point in the semester, sometimes it surprises me that there are things that we haven't previewed. Previewed so many other things, but one of the things we haven't previewed, I guess we did a little bit in using your calculator, but we haven't really previewed negative exponents. So we're going to need to be able to be very, flexible on this negative exponent thing. And not just flexible, but I mean, we have to be immediate. We have to be able to do what we're supposed to do with these negative exponents. So I'm relying on something that we did preview, and that is patterns. We know patterns better than anyone else in this part of the book because we previewed that idea. So I have what I called, the exponent, the meaning, and the answer. Now, that only works so far in this problem. And what we're doing is we're going to rely on patterns as soon as we need to. But what I can write is 2 cubed means 2 times 2 times 2, 3 of a kind, 2 to the 3. And that answers 8. And 2 squared means 2 times 2, and that answers 4. And 2 to the 1 would just be a single 2 here, and that answers 2. And here's where patterns are going to come in. I have to notice that if I go this way, I'm dividing by 2 every time. And let's continue the pattern. When I say continue the pattern, 3, 2, 1, well, that's going to be a 0. So what we're doing here is we're throwing it out to the universe. What would the pattern tell us we would get if we continued dividing by 2? Well, 2 divided by 2 is 1. So this may be the first way that, the very first caveman discovered that 2 to the 0 equals 1. It's not intuitive because we don't really know what it means. What's 2 to the 0 mean? 0 of a kind, right? If 2 to the 3 means 3 of a kind, 2 to the 0. We don't really have an explanation for what it means, but the pattern certainly tells us it's 1. All right. Well, to further, to keep the pattern going, how about 2 to the minus 1? Well, divide by 2. Did I get that? Software has a mind of its own. Okay. All right. I want to divide by 2. Well, 1 divided by 2 is 1/2. And again, we'll figure it out in a minute, but we don't really know what to put here. We'll put something there, but we know the answer is 1/2. We just don't know what it means, I guess. At least the pattern hasn't told us that yet. Divide by 2. 1/2 divided by 2, 1/4. Divide by 2 one more time, and we get 1/8. So maybe you see it. Remember this thing started, I have a 1/8 here for 2 to the minus 3, and I have an 8 here for 2 to the positive 3. So what that suggests is 2 to the negative 3 really does have a meaning, and the meaning is no longer a mystery to us. It is 1 over 2 to the 3, or 1 over 8. This means 1 over 2 squared. This just means 1 over 2 to the 1, or 1 over 2. So negative exponents have a meaning. So I'm saying we just discovered, using patterns, that x to the 0 equals 1, and x to the negative n means 1 over x to the n. So these are facts we're going to use, well, maybe not this one right now, but this is the fact that I'm going to use on this next problem. All right, so the problem, I have too many steps. I don't want you to look ahead right now. The problem in section 5.3 looks like this. X to the minus 1, y to the minus 1, x to the minus 3, y to the minus 3. And what do we know? We know that we can change all of the minuses to 1/overs of their positive value. So we do that. And by the way, that's the only step you can do on this problem. If this were a multiplication, it might be a different story, but in this case, you just have to create this 4-story building, this fraction with numerator, denominator, but it's only temporary. All right, now the book calls this thing I did right here method 2. Yeah, method 2. Terrible name for a method. It doesn't really mean anything to call it method 2, but basically the idea here is an idea we're familiar with, though. I want to cancel all of these denominators, all 4 of them, and I can do that by multiplying the top and bottom by exactly the same thing. Be sure to multiply the top and bottom by exactly the same thing. If you multiply the top by something different than the bottom, it's no longer equal to the original problem. Another way to say that is, if you multiply the top and bottom are the same, you're multiplying by 1 or a form of 1. So multiply by 1, and you get, well, I just distributed here. You get this. Now, what that is going to do is this x is going to cancel with one of those x's, and this y is going to cancel with one of those y's. And this x cubed is going to completely cancel with this x cubed, and this y cubed is going to cancel with that y cubed. So the purpose of multiplying by what we did was to cancel all of the fractions. So I no longer have this 4-story building. If I cancel all the fractions within the fraction, I just have a normal fraction. A normal fraction with letters in it. All right, so this particular problem is solved the way we solve problems in section 5.1, and that is we factor and cancel anything that's similar in the numerator and denominator. So factor and cancel, and looks like our final answer is going to be this surviving x squared y squared, and this whole thing that survives there. So that is section 5.3. I hope you see how important pretty much everything we've been doing is on this problem. In other words, it brings up a lot of stuff. Factoring sum of cubes, I did that from this step to this step. Factoring out the greatest common factor, clearing fractions, all of the things that we've done. And then this idea that's a little bit new to chapter 5, and that is, just isolate this one. Y to the minus 3 is 1 over y cubed. It's that thing I just went over here. Right? So a lot of things going on here. A lot of opportunities on this problem to make a wrong turn. And what I mean by that is sometimes students will just try something that doesn't work. What are they? Sometimes students think there's something you can do with this 1 and this 3. No, when it's negative and you have a plus sign here, just use the 1 rule that we have. Change the minuses to these fractions. All right. The other thing is sometimes students are tempted to multiply the top and bottom by something different. Has to be the same thing in order to keep it equal. So look over this example. It is an example in section 5.3. Hopefully you see the right way to do it. They aren't terribly long questions. They do take a little bit more ink than some of the problems we do, depending on how much writing you're going to be doing here. But the ultimate goal is to get something that just looks like a fraction or simpler. There's never a reason to have a final answer that has 4 stories in it like this. All right, that is complex fractions, because they have a fraction inside a fraction, and that's section 5.3.